Out there in the universe is a planet that is 10 times the size of Jupiter, completes one circle around its star in less than 24 hours, and shortly spirals onto the surface of its searingly hot sun. Here is planet WASP 18b, too huge and too close to its sun for comfort. This planet orbits a star 1,000 light-years away from Earth, which defies the laws of physics. The two enormous objects should be drawn together in a lethal gravitational embrace by the tidal interactions between them. Even though the planet is at least 1 billion years old, if things continue as they are, it won't be much longer before it collides with its own star, bringing itself to an imploding doom. With a planet like this out there somewhere in the universe, we cannot help but ask, are there others like it? What makes each of these planets strange? Are they habitable? And what strange characteristics do they exhibit when compared to ours? Join us as we bring you the strangest planets in the universe that defy all logic. It's a universal human question of whether or not we'll ever be able to move on from our current planet to live on another. There are planets beyond our solar system that may be just suited for life to thrive, but as astronomers discovered new worlds, they stumbled across extremely odd planets where life appears impossible. How is it possible for one planet to be hotter than the Sun while another is larger than its star? How is it possible that there may be a place that can be likened to the biblical description of hell? One of the planets in question is 55 Cancri E, also called Janssen. This is a diamond planet, so to speak. Diamonds are a wonderful investment. They're quite valuable to start, too. You might or might not be able to turn one into a pickaxe. However, you'll have to go somewhere else because 55 Cancri E regrettably isn't on your side. The exoplanet, which is 4.1 light-years away, reportedly orbits the Copernicus star, according to NASA. In terms of astronomical distance, this one can be seen as a close neighbor. The remarkable thing about this planet is how close it is to its star. To put it into perspective, it is around 1/4 the distance between the Sun and Mercury. Additionally, this planet bears the nickname Planet Hell due to its close proximity to the Sun. This assumption is based on NASA's assertion that the planet's day side is covered in oceans of lava due to temperatures exceeding the melting point of most common rocks. If Earth were considerably closer around the Sun than it is right now, what might it look like? So close that a full year is only a few hours long. Because of gravity, one hemisphere is permanently engulfed in sweltering sunlight while the other is doomed to perpetual darkness. So close that lava begins to fall from the clouds, the oceans begin to boil and rocks begin to melt. Imagine it. Nothing precisely like it exists in our solar system. Another noteworthy feature of the planet is that it's believed to be tidally locked but lacks a hotspot on the hemisphere that faces its star. According to the explanation proposed to explain this anomaly, the planet has a dynamic atmosphere that rotates and moves the planet's hot spot continuously. In order to ascertain whether or not the exoplanet's atmosphere is primarily made up of oxygen or nitrogen, scientists will now use the James Webb Space Telescope to observe it. Interestingly, while having a horrible climate, it is not currently the hottest exoplanet that we are aware of. That accolade goes to Kelt 9b, the ultimate sauna, 650 light-years distance from us. Kelt 9b is the world's hottest planet and the ancestor of what astrophysicists refer to as ultra-hot Jupiters, a term that lacks imagination. These Jupiters have surface temperatures of more than 2,000 degrees Celsius. Nearly 5,000 degrees Celsius is the average temperature on Kelt 9b, which is 2,000 to 2,500 degrees Celsius hotter than the second hottest planet ever discovered. In actuality, 5,000 degrees Celsius is a higher temperature than the photosphere of many stars. This exoplanet is so hot, according to NASA, that no solid structure could exist on its day side, since even molecules would be destroyed into atoms. But how is it that this planet's temperature is unnaturally high? The planet orbits a star that is nearly twice as hot and more than twice as heavy as the Sun, with an orbital period of just 1.5 days, which is the primary cause of this. The temperature of the photosphere of Kelt 9, the host star, is roughly 10,000 degrees Celsius. Kelt 9b is a hot Jupiter that, like all other hot Jupiters, always faces the same direction from its star and is characterized by powerful winds that push hot gas from the day side to the night side and vice versa. The difference is that on Kelt 9b, the day side temperature is so high that even the night side, which is never exposed to the stellar light, is unable to cool to temperatures below 2,000 500 degrees Celsius. This is in contrast to classical hot Jupiters, where the not too extreme dayside temperature enables the gas to cool down considerably on the night side, even leading to the formation of clouds. There is no way that life could possibly develop here. This planet has an egg-like form similar to that of WASP-12b, which will be discussed shortly, but not to the same extreme because Kelt 9b is not only somewhat larger than WASP-12b, but also twice as heavy, which means that it has higher gravity and a longer orbital distance. Although Kelt 9b is likewise losing atmosphere at a rapid rate, it is conceivable that the atmosphere will still be present when the star engulfs the planet in a few hundred million years. In contrast to WASP-12b, this engulfment occurs because the star will soon cease to exist as it is, not because the planet is steadily approaching the star. The possibility exists that Kelt 9b will someday evaporate or be consumed because it is nearly twice as hot as our Sun. The star will start to grow significantly during the next few hundred million years, swallowing the planet, which will then quickly spiral into the star, where it will be shattered into bits and annihilated. And that brings us the planet that is the victim of cannibalism, WASP-12b, 1,400 light-years away from us. This planet is what is referred to as a hot Jupiter, meaning it's roughly the same size and mass of Jupiter, but orbits the host star very closely. A star that is a little more massive and hotter than the Sun is orbited by WASP-12b in just over a day. In actuality, the photosphere, a term used to describe the part of the Sun that emits the light that human eyes can see, is about 5,500 degrees Celsius, while that of WASP-12, the host star, is about 6,000 degrees Celsius. The planet's temperature is on the order of 2,000 degrees Celsius due to the warmth of the host star and the close orbital distance. Just one stellar diameter separates the planet from the star's photosphere. The length of a day is equivalent to the length of a year for planets that circle so close to their host star as WASP-12b, which means that the planet constantly faces the same direction toward the star as the Moon faces the Earth. Like the previously mentioned Kelt 9b, several hot Jupiters are known to experience temperatures of up to 2,000 degrees Celsius. However, WASP-12b possesses a quirk that is not shared by many. The planet's relatively large radius for its mass suggests that it has low gravity. This, combined with the planet's close proximity to a massive star, causes the planet to become deformed, taking on the shape of an egg with its pointy side facing the star. This is a common trait of hot Jupiters, but in the instance of WASP-12b, this elongation is extreme. The planet's radius is about twice as large in the star's direction as it is in the perpendicular direction. The form of the atmosphere, coupled with the planet's low gravity and high temperature, causes a powerful and continuous flow of gas from the lower to the upper part of the atmosphere. The gas is then ejected into space and drawn into the gravitational pull of the host star nearby. As a result, a sizable amount of gas is continuously flowing from the planet towards the star as it revolves around the star. It would be as if the air we breathe continuously flowed upward, reached the altitude at which stratospheric balloons fly, was ejected into space at high speed, and was then sucked up by the Sun. This is how it would appear on Earth if we mirrored this. Because the star and planet have such a large mass difference, the star won't even notice that it's eaten its planet, and there won't be any leftovers. Imagine being murdered without even your murderer noticing. It's a sad thought. WASP-12b is undoubtedly neither a place where life could develop, nor a place where one could go on vacation and unwind. But what about WASP-76b, the exoplanet where molten iron reigns? This planet is tidally locked to its star BD plus 01316. It has blistering temperatures about 4,532 degrees Fahrenheit, 2,500 degrees Celsius, which is hot enough to melt iron because that side of the planet is always facing the star. The side of WASP-76b that faces away from the F-type star is constantly dark, while the other side is burnt by radiation that is hundreds of times greater than that which the Earth receives from the Sun. Even while the planet's day side experiences extreme heat, this does not imply that the planet's night side is any more comfortable or less dangerous. The side of WASP-76b that faces away from the planet's parent star is cooler by at least 1,832 degrees Fahrenheit, 1,000 degrees Celsius, but this implies that iron vapor is cooled as it's blown across the hemisphere by tremendous winds, forming liquid droplets. droplets of molten iron fall to the cooler side of the planet, hitting it with a torrent of heat. This kind of rain is common in many other worlds besides WASP-76b. As is frequently the case, new discoveries of exoplanets not only increase the stakes, but also make things even stranger. Up next is a world of ice and fire, Andromeda B, Upsilon. Another exoplanet, Upsilon Andromeda B, orbits its host star in less than 5 days, suggesting that it's most likely tidally locked. This planet, formerly known as Safar, is an extreme world due to the enormous temperature difference between the day and night sides. During the day, the temperature increases to 2,912 degrees Fahrenheit, 1,600 degrees Celsius. However, at night, it lowers to -4 degrees Fahrenheit, -20 degrees Celsius. This implies that traveling across a hemisphere on this planet is similar to jumping into a volcano. The temperature disparities between this hot Jupiter's star-facing and star-ignoring sides seem to be far greater than those of the other tidally locked hot Jupiters we have observed. This exoplanet's extreme temperature difference may be caused by its parent star, Upsilon Andromedae A, which is very massive and has a hot zone virtually immediately overhead of it. In addition, if you share the opinion that life on Earth is akin to hell, you should visit planet K2141b. In addition to its molten lava oceans and supersonic winds, this planet, hundreds of light years away from Earth, boasts boulder-forming rain. Researchers have labeled the strange, hellish exoplanet one of the most extreme finds ever made. Scientists discovered that the planet's atmosphere and weather cycle were exceedingly unusual. The surface, ocean, and atmosphere of the exoplanet appear to be made of the same materials. Guess what these things are? Rocks. According to an examination of the world's illumination pattern, almost 2/3 of the planet experiences continual daylight. The same side of K2141b always faces the star because of gravitational locking by its proximity to its star. This scorchingly hot area of the planet experiences temperatures that can approach 5,400 degrees Fahrenheit. The temperature is high enough to melt and vaporize the rocks, creating an inhospitable environment. The rest of the planet is absolutely black, and it gets down to -328 degrees Fahrenheit there. Water on Earth evaporates, condenses, and then re-evaporates, producing rain. Imagine the same process occurring without water in K2141b, which has just rocks to work with. Mineral vapor is transported to the planet's dark side by supersonic winds traveling at over 3,100 miles per hour, when sodium, silicon monoxide, and silicon dioxide vaporize to form a mineral vapor. When rocks rain back down into the 60-mile deep magma ocean, the cycle is then resumed. This cycle is not as stable as the one on Earth, say scientists. It takes longer for the magma ocean to migrate from the night side to the day side. Experts predict that as time goes on, the mineral composition will change, radically altering the planet's surface and atmosphere. Just be grateful that Earth's occasionally intense heat wave doesn't last forever and causes boulders to rain down from the sky. As is often said, not everything that glitters is gold. This is the case with HD 189733b, where showers of molten glass are falling. The distance of this terrifying world from Earth is merely 64 light-years, making it the closest hot Jupiter to our planet. It may look like a lovely deep blue marble floating serenely in space, but if you dared to approach this enormous gas giant, you would swiftly come to regret your choice. This gas giant planet revolves around its star every 2.2 days, and it turns out that the planet's gorgeous blue hue is a result of its deadly weather, particularly its glass-melting rains. But when it comes to the planet's strange weather patterns, this is simply the tip of the iceberg. The exoplanet also experiences winds of about 5,600 miles per hour, 9,000 kilometers per hour. Instead of falling straight down, glass rain on the exoplanet curves sideways toward the ground, and supersonic winds collect silicate particles and turn them into tiny missiles. For a planet of this size, this exoplanet has a far higher atmosphere than astronomers would predict. Depleted atmospheres can sometimes be granted a second shot, as the next extreme exoplanet we'll be talking about shows. And that is Gliese 1132b, the planet where a second atmospheric layer formed. Yeah, like a second chance at life. Surprisingly, our planet and Gliese 1132b share a lot of similarities. It has a little bit more mass and a little bit more radius. It shares a lot of traits with Earth and is 4.5 billion years old. This world, which orbits its red dwarf parent star in just 1.6 days, as opposed to the typical Earth day, is unique for one reason, despite its close proximity to the star. The exoplanet Gliese has a surface temperature of 278 degrees Fahrenheit, 137 degrees Celsius, which is significantly higher than the average temperature of our planet, which is 68 degrees Fahrenheit, 43 degrees Celsius. This intense radiation is also robbing the exoplanet of its atmosphere. However, it has just been found that Gliese 1132b is going through an odd behavior. Tidal forces produced by the planet's star, which is 20 times bigger than the Sun, are squeezing and stretching the planet. Explosive volcanic activity and a rush of gases to the planet's surface are caused by this flexing. These kinds of gases are essentially creating a second atmosphere all around the planet. Astronomers have never seen anything like this before. But because of its origin, the regrown atmosphere presents a rare opportunity to study the chemical composition of an exoplanet indirectly. Now, imagine if the Sun and Earth are constantly engaged in combat. What a tragedy for us that would be, right? Corot 2b, a planet located 880 light-years away, is now being destroyed by its star, Corot 2a. It's dangerous to orbit the parent star more than 2 million miles away in this region of the universe. Corot 2b is a gas giant-like planet that we all feel sorry for, and we hope that there was never any life on this planet in the first place. The brave exoplanet is currently 1,000 times the size of the Earth, but it is shedding 5 million tons of mass every second. This planet is being fully fried by its star. Even stranger, it's possible that this planet is influencing the behavior of the star that is bombarding it. When the Corot satellite of the French Space Agency discovered this hot system in 2008, no one expected it. It's estimated to be anything from 100 million to 300 million years old. The parent star is assumed to have finished forming, but because of its tremendous magnetic activity, it is still emitting dazzling X-rays that are evocative of newborn stars. What could be the cause of the divergence that exposes Corot 2b to radiation that is 100,000 times more intense than what we experience from the Sun? The star may be spinning faster because of this planet's closeness, which might keep its magnetic fields active. Without the planet, the star might have lost the instability of its early years millions of years ago. It's possible that, if you somehow manage to land on this planet, you'll be dragged away by its star and subjected to extremely high radiation levels from the planet's resources as well as the star itself. If that's not a horrible death, then I don't know. In a galaxy far, far away, there's Kepler 10b. Kepler 10b orbits its host star at a distance of 1/10 of the orbit of Mercury, similar to the Sun. As a result, the orbit is shorter than an Earth day, and the surface temperature is higher than 2,372 degrees Fahrenheit, 1,300 degrees Celsius. Due to its tidally locked relationship with its star, Kepler 10b emits silicate droplets and molten iron. To put it another way, the planet probably possesses lava that's hotter than the material on Earth. The planet Kepler 10b has lost most of its atmosphere due to radiation from its host star, but stellar winds have blown these atmospheric droplets away from the planet's surface, giving it a blazing tail. The resulting world, which resembles Earth but is dominated by lava, is called an abomination by astronomer Dimitar Sasolov. If this exoplanet's surface is coated in molten lava, it's no surprise that it's been likened to Mustafar, the planet in the Star Wars world where Obi-Wan Kenobi and Anakin Skywalker faced off. Due to his horrible injuries from the lava on the planet, the young Jedi is forced to put on Darth Vader's well-known black armor and breathing apparatus. A world with a cooler climate would be advantageous when choosing where to engage in a duel to death, don't you agree? And of course, there are many exoplanets to choose from, which is a blessing or not. For all we know, exoplanets are all violent, scorching worlds that revolve around their parent stars. But this is far from the truth. That leads us to HR 5183b, the planet of whiplash. In terms of exoplanet discoveries, this super Jupiter, which is 3 times as massive as our largest planet, has a very eccentric orbit. This gas giant orbits its parent star, HR 5183, in an egg-shaped pattern, unlike other planets. Astronomers identified the exoplanet because of a decrease in brightness caused by a little wobble the planet's gravity causes on its parent star. The process was completed after 20 years of observations with 3 telescopes, including Hawaii's W.M. Keck Observatory. Despite the extended observation period, the planet has not yet completed a full orbit, which is expected to take between 45 and 100 Earth years, or most likely 74 years. Its unusual orbit, which sees it linger on the periphery of its system before slingshotting into the center and whizzing by within a hair's breadth of its host before bursting away, is what makes it noteworthy. The erratic behavior of the Whiplash planet, as it's known, gave it its moniker. A wrecking ball analogy has also been made because of the potential devastation it will wreak to any other planets in the system that attempt to orbit more conventionally. If HR 5183b's weak connection to its parent star is a surprise, some planets have gone even further, severing all ties to them and exploring the universe independently. Exoplanets come in many different forms, sizes, and densities, but they all revolve around a star, right? Well, that's wrong. PSO J318522 is a cosmic loner 80 light-years away from us. So far, we've encountered planets where life is not possible, typically due to the characteristics of their host star and/or their orbit. PSO J318522, on the other hand, is the exact opposite. It lacks a star and, as a result, cannot support life. Known as a rogue planet, PSO J318522 floats aimlessly through the cosmos without ever making an orbit around a star. The fact that this planet is young is what allowed us to discover it. Young planets are still contracting, which causes their internal temperature to rise and causes them to radiate infrared light. This planet is 1.5 times bigger and nearly 6 times more massive than Jupiter. Because of the internal heat coming from the inside, the temperature of the portion of the planetary atmosphere that emits light is about 500 degrees Celsius, but in contrast to what happens with planets illuminated by a star, the temperature decreases steeply with increasing altitude, up to the freezing temperature of outer space. This planet has been condemned to an endless night, which cannot be regarded as a potentially habitable condition. Meanwhile, there dwells a dangerous lighthouse 30 light-years away known as AU-MIC-B. It's called a super-Earth because it's less than 10 times the mass of Earth and only slightly larger. AU-MIC-B revolves around its host star AU-MIC, which is about 2 times as light as the Sun and has a photospheric temperature of about 3,500 degrees Celsius, making it noticeably cooler than the Sun. It's an 8-day trip around AU-MIC, the host star. Only 20 million years old, this system stands in stark contrast to the hundreds of millions of years that these stars have lived. Like people, stars like AU-MIC and the Sun go through phases of high activity and low activity as they mature. It is common to see explosions and eruptions from a star that is currently active. It is the ejection of charged particles, so-called coronal mass ejections, and the emission of X-ray radiation that follows these explosions into space. The Sun, on the other hand, occasionally unleashes such eruptions, although they are far less powerful and occur far less frequently. These coronal mass ejections and the X-ray radiation that reaches the planet have 2 effects. The particles ejected by the star during an eruption first penetrate deeply into the planet's atmosphere, kicking away some of the gas that makes up the atmosphere, while the X-rays heat up the upper part of the atmosphere, which will expand and escape into space if the planet is not shielded by a magnetic field like the Earth is. As a result, the planet's atmosphere gradually thins, although this isn't necessarily bad for the emergence of life. We'll get to that in due time. Second, the X-ray damaged molecules are destroyed. This suggests that if molecular bonds, such as those holding DNA together, could develop on the planet's surface, they would be destroyed every time a powerful outburst occurred on the star's side that faces the planet, which would occur roughly every few hours. Because all old stars were previously young stars and thus active, it's interesting to note that Earth has experienced what AU-MIC-B is experiencing right now. Because it's one of the few young planets and one of the nearest to our solar system, AU-MIC-B is a unique object in the universe. Observational signals used to discover planets are impeded by the strong activity of young planets, which makes it harder to find them. It's crucial for the emergence of life on a planet that young stars cause planets orbiting near enough to them to shed their atmosphere. Most planets are thought to be born with a thick atmosphere made largely of hydrogen. Hydrogen is a highly efficient greenhouse gas, making life on a planet's rocky surface nearly impossible if the atmosphere is covered by it. Hydrogen is able to be removed from rocky planets by young stars, allowing for the possibility of an atmosphere with a more complex composition that could be favorable to the emergence of life. Moving on to TOI 849b, our dear poor planet. According to NASA, every day is a bad day on this planet. The G-dwarf star TOI 849 is located 741 light-years away in the Sculptor constellation. The star, which is 6.7 billion years old, slightly less massive and smaller than the Sun, is also known by the catalogue numbers TIC 33595516 and TYC 6431-11581. TOI 849b has an abnormally large mass of 39.1 times that of the Earth, which is almost half that of Saturn. It has a smaller radius than Neptune. On TOI 849b, which was found in 2020 by NASA's Transiting Exoplanet Survey satellite, there is absolutely no fun. This exoplanet revolves around its star so quickly that a year only lasts 18 hours, while its atmosphere slowly disintegrates. Do not even consider hosting a birthday party if you have the slightest chance of visiting, because there won't be any atmosphere and the temperature of 1,530 degrees Celsius will cause the cake to melt. What distinguishes TOI 849b is its peculiar hybrid nature. The majority of worlds of this size are gaseous. Contrarily, this one is a rocky, dense world that is 39 times bigger than our own. The planets already mentioned are undoubtedly inhospitable to life and have some bizarre traits, but overall they are quite typical planets. Instead, PSR J1719-1438b, about 3,900 light-years from Earth, is beyond the realm of possibility. This planet orbits a neutron star in a little over 2 hours and is heavier than Jupiter. After supernova explosions involving stars more massive than 8 times the Sun, neutron stars are what is left. These explosions have the greatest energy in all of nature. After black holes, which have a significantly denser matter, neutron stars contain the second densest matter that is now understood to exist. PSR J1719-1438, the host star, is 4 times as massive as the Earth, yet somewhat more massive than the Sun. This indicates that on average, a 1 centimeter cube made of neutron star stuff weighs around 30 kilograms. Osmium, which is the densest element on Earth, weighs barely 22 grams in a cube of the same size. So why is a world like that not suitable for supporting life? First, the optical and infrared light that we see with our eyes and that heats the Earth to its current temperature, respectively, are emitted in extremely small quantities by neutron stars. For instance, planets would not be able to begin photosynthesis in such a setting. However, even if it were possible to illuminate this planet with optical and infrared light, the neutron star's radiation would vaporize and kill any life that was already there. This is due to the fact that neutron stars produce a significant amount of X-ray radiation, which effectively separates molecules. The planet is unquestionably too close to this star, which is the ideal life killer, to be anywhere close to an environment that could support life. How is it possible that a planet could be circling such a massive explosion's remnants? This is something we can only conjecture on. Starting with the premise that no planet can live near a supernova undamaged, there are 2 possibilities. One possibility is that the planet was wandering through space, maybe on the boundaries of another planetary system, and that the neutron star caught it, placing it in the orbit that it's currently in. This suggests that the planet may have transitioned from a state in which it was getting little to no stellar light to one in which it is receiving a significant amount of extremely intense radiation, an enormous shift. The other option is that the planet developed after the supernova explosion, most likely from the debris the dying star had spewed. Moving on to the darkest exoplanet identified so far, TRES 2b. It's so black, you can hardly make out its shape. Light just seems to fall into it. Hitchhiker's Ford prefect may have been referring to hot black Desiato's limo, but he may just as well have been referring to TRES 2b. It was discovered in 2011 by NASA's Kepler Space Telescope and is the darkest known exoplanet, reflecting less than 1% of the light it receives. Known as TRES 2b, it is the dimmest planet or moon ever identified, circling a star some 750 light-years away in the constellation Draco. In terms of opacity, it's comparable to the darkest acrylic paint you could use to paint with, and that includes black coal. How depressing this planet is simply ludicrous. It's possible that despite all of these extreme worlds, we can yet find the most remarkable exoplanets, and that they may be found in systems that we haven't before encountered. Are there any of the planets we mentioned that you would ever like to visit? Let us know what you think in the comments section below.